Greetings, A-level chemists. Okay, welcome to a rates reaction question, and we're looking at the continuous monitoring of rates, specifically looking at the iodination of propanone. So this is a reaction that we should be familiar with, okay, irrespective of exam board, I'm going to say. So we've got I2 reacting with propanone, and we've got an acid catalyst, source of that is HCl. And we're using a colorimeter, so UV vis spectroscopy, to measure how the absorbance of I2 changes over time. Okay, and the first question is, why does the absorbance decrease during the reaction of I2 with propanone? Well, I2 in aqueous conditions is a brown solution, okay? So I2 aqueous is a brown solution. And it's a reactant. So what's going to happen is the I2 concentration is going to start off high because it's reactant, and then as it reacts, the I2 concentration is going to decrease, and as it's used up, the absorbance is going to go down. So the concentration of I2 decreases as it reacts, therefore the absorbance decreases too. And remember that the concentration is proportional to the absorbance, okay? And we can also say, for no extra marks, that the products are colorless. So the reaction is monitored by the colored reactant, okay? So the reactant which has a color, and that is I2. So there are your 2 marks. Okay. Now, this is a cracking 2 marker. There's quite a lot going on for this though. Okay, so the question is saying determine the I2 concentration at time equals 0. Okay, and we have some info here about the I2. We know that there is 1 centimeters cubed of 1 mole per decimeter cubed I2 solution. So we can work out the number of moles of I2. The number of moles of I2 are given by the volume, which is 1 centimeters cubed, over 1,000, we're converting to decimeters, multiplied by the concentration of 1 mole per decimeter cubed. So this is equal to 1 times 10 to the minus 3 mole. And now we're going to work out the concentration of I2 at t equals 0. This is at 0 time. And to do that, what we need to do is add up the total volume. So the total volume is 49.5 and 49.5 and the 1. Don't forget this 1. So you got 1 centimeters cubed plus 49.5 plus 49.5. So 49.5 times 2 is equal to 99 centimeters cubed. 99 plus the 1 is equal to 100 centimeters cubed. So that's my V total. So that's my total volume, okay? So then what we're going to say, that the concentration is equal to the number of moles, which is 1 times 10 to the minus 3, over V tot, which is 100 times 10 to the minus 3. If we get it into decimeters cubed, just cancel these out. So this is 1 over 100. So this is 0.01 moles per decimeter cubed. Okay, and now we have to then determine what the concentration of I2 is at time equal to 500 seconds, given that the absorbance is 0.18. Okay, really lovely question. So what we can do is determine that scale factor. And we're scaling down, okay? So this is going to be 0.18 over 0.80. So what does that equal? Let's work that out. So this equals 0.225. So what we can do is simply multiply 0.8 by 0.225. Be better if I actually left some room. So we're scaling down by that factor. And then whatever we scale down by on the left hand side, we're going to scale down by on the right hand side. So if we times 0.01 by 0.225, we will also get, what will we get? 0.00225 moles per decimeter cubed. And there you go. Really, really nice question. Okay, let us continue. So now we have to plot a graph of absorbance versus time, and what I'll do is, rather than showing this, I'll plot it and then restart the video. So in the words of Blue Peter, here's one that I've made earlier. So we've plotted a graph of absorbance versus time. So now I need to draw a best fit line on my graph. Okay, so we can do that in black. Let's have a look at what my best fit line might look like. Something like that. That looks reasonable to me. That looks pretty good, actually. That looks reasonable to me. Okay, so there is my best fit line. Done. So from my graph, I now have to determine the order of reaction with respect to I2. Remember, we're looking at the absorbance of I2, so hence we can determine the order of reaction with respect to I2 because absorbance and concentration are proportional. So let's go. The order is 0 with respect to I2. This shows that the rate is independent of the I2 concentration. Okay, so even though the I2 concentration is changing, the fact that the I2 concentration is changing, and if we were to determine the gradient of this line, we will see that the gradient is constant. So the gradient in this case gives us the rate. So the rate is constant. So therefore independent of the changing I2 concentration. Really nice question. Okay, and that links quite nicely then into mechanisms. So a student proposes a 3-step mechanism for this reaction. Now, we have to add steps 1 and 2 to the proposed mechanism shown below. So it tells me step 1 is slow, so straight away that is the RDS, that's what I'm thinking, okay? All right, if that is the RDS, where do we go next? So then I'm thinking that this intermediate in step 2, which goes on to react, must have been formed in step 1. Okay, it must have been formed in step 1, so this must be the product of step 1. Okay, if that is the product in step 1, what must the two reactants be such that this is the product in step 1? Well, it must have been propanone and H+. Then what can we say? From this, I can infer that the rate equals K CH3COCH3 multiplied by the concentration of H+, because we're just looking at the species in the RDS, those correspond to the species in the rate equation and the molecularity as well. Perfect, great. So then what happens is, this is an intermediate formed in step 1, which goes on to react in step 2. Okay, and then this must also be an intermediate in step 2, and let's see what that intermediate goes on to form. So let's have a look. So I take this product from step 2, this intermediate, and I place it down as one of the reactants in step 3. So let's do that. So this is going to be H3C. Put my double bond there. Okay, so now I need to think, what else do I need to react? And I look at the chemical equation. So I've got one molecule of propanone reacting. Okay, the H+, which is a catalyst, is used and reformed, so just ignore that. It doesn't appear in the overall equation. So then what I haven't used so far as a reactant is I2. So let's put the I2 in step number 3. And if I put the I2 in step number 3, presumably I make this reactant and I make HI. All right, let's have a look. So I make H3C, or CH3, CO, CH2, I plus HI. Now, how can we tell if we are correct? What we need to do is add up all of the steps of the proposed mechanism. Now, if we add up all of the steps of the proposed mechanisms and cancel out terms that we can cancel out, like any intermediates, if we generate the full chemical equation, then this is a suitable, doesn't have to be the actual mechanism, but this proposed mechanism would be feasible. Okay, so let's think about this. So we've cancelled out everything that we can cancel out. So then if we add up all of these steps, we've got one molecule of this, which is propanone, one molecule of I2, forms CH3COCH2I plus HI. And we get the actual chemical equation, so this looks good to me. Okay, thank you for watching. I hope that was helpful. That was a nice, solid kinetics question. Ta-ta.